It's time to get down to the nitty gritty. Finally. Welcome back to Freedom Hillbilly. Now, we've already established our frame of reference. We've nailed down our origin for the coordinate system, and we've set up 3 prism rods over 2 property bounds and 1 monument that may or may not be a property bound. Turns out not to be, but we don't know that. They're all line of sight, and we're going to show you how to use the TRS, Total Robotic Station, to let it know that we're where we're at. Because it has no idea. It's clueless. It's dumb. Doesn't know what it's doing. So we've set up the TRS over our point, our unknown point, our free station point, our occupied station. Yeah, it's here. And we've leveled it, went through its component cycle. So we're all set to site to the 3 points, get them onto our grid. So a note before we start. We've already downloaded an area file called TRS for, you got it, Total Robotic Station. Or Trimble, doesn't matter. And it has 1 point on it, and that's our origin. So now that we have that, the first thing we want to do is measure the distance from our origin, point A, to our other bound, point B, and that will be our northern coordinate for point B. So let's get started. Now you could measure that distance 2 ways, with program 26 or with program 24. Let's start off with using program 26 to measure that distance. So program 26, that's distance to object. From file or measured, we're going to use measured. It's asking for a job number. Let's just give it TRS. So alpha TRS. And we like all those settings, so we hit enter to accept them. From point number, the first point is going to be A. So shift A. Target height, we've set that prism up to 8 feet, 8.0. We sight the point in, hit aim, it's measuring, and it gives us horizontal angle, vertical angle, sight distance, or slope distance. Horizontal angle, we don't know yet, this is just sort of random. And that doesn't matter yet. So we're going to registrate that point. Now we're going to go to point B. Shift B. Enter. Target height. The target height for point B is 6 feet. Now we're going to swing this guy around and see if we can pick up point B without tripping over ourselves and having the sun in our eye. We aim. And now, whoops. And now we're going to registrate that point. We hit enter. It gives us our elevation differential and our grade. And we want to store it? Sure. More? No. And then it pops us back to P0, which is the local mode. And there we have it. So for program 26, the measure angles and distances, the results of those measurements and all that data is stored in the job file, which is different from your area file. I don't fully understand the difference between those two. But typically, job files store results of something that you're doing. So, not always, because if you go into measure coordinates, it's putting those coordinates in an area file. But let's say you're doing a stakeout, and you go over those points, it'll store the actual location in the job file as opposed to the desired points, which are in the area file. And so let's just go into it. Hit menu. Number 2 is the editor. Number 1 is internal memory. Hit enter to go by the how much available memory screen you have. And the job number is TRS. Now let's go to the beginning of the file and step through the file. So active equals 99. Don't know what that means. We do know Agent 99. She's a cutie. We're Agent 86, if you remember that. Anyway, they never 86'd 86. Did you notice that? Okay, so point number A and point number B. The horizontal angle between the two was 38 degrees, 23 minutes, 24 seconds. We don't care about that. The horizontal distance, which is what we do care about, is 562.05 feet. Now, I think our sketch said it should have been 34 rods, which is 562 feet, I think. Whatever 34 times 16 and a half works out to be. But that's pretty good. We're close. Maybe it's 561. The difference in height between the 2 points is 49.69 feet. The grade is 8.8%, which seems right. And that's it. So now what do we want to do? Well, we want to create our coordinate system. We want to have point A in our area file. We want to have point B in our area file. And then we want to start adding other points for the topographic survey, like our monument, into that same file. So in order to do that, we have to use program 43, enter coordinates. So let's go ahead and do that. So let's exit out of the editor. We're back into standard mode with P0, which is local. Now we can enter program 43. Enter coordinates. It's going to be an internal memory, so 1. Now we have to enter the area file name. Use the alpha key for TRS. Total Robotic Station! That's right. We're going to measure heights. So let's just say no. Our first number is going to be point A. So shift A. The point code is going to be a bound. So alpha BND for short. Just BND for bound. Because it's a property bound. And the northing was 0. The easting is 0. And we're going to store that. Yes. Now the next point is B. So shift B. And it's also a bound, so we'll just accept its default. The northing, well, we measured it from, we just measured it. It's 562.05, 562.05. And easting, we're going to say it's 0. We're saying that point B is due north. Store it, yes. And we're done. So just hit enter again, and it'll pop you out because you didn't enter anything. And it brings us back to our local mode P0. So now if we go in, let's just check it to make sure that we have it. So menu, editor, number 2, internal memory, hit enter. The job number, now remember we want to go to the area file this time. So let's go to the dir, switch it to the area files, defaults to TRS, that's the one we want. So we could hit enter to open that file. Now let's go to the beginning and step through it. First point, measured point is 0 station. This is the one we entered back at the office. It's a station, 0, northing, easting, 0, elevation 1000. Now, our first point is A, which is our first bound, which is also at the origin, because we defined it that way. It's a bound, northing 0, easting 0, point B, which is our second property bound, is a bound at 562.05, easting 0, and that's it. So now we have our frame of reference, we have our coordinate system pinned down, we have a file that has our 2 property bounds within that coordinate system defined. The next step is to actually tell the robotic station where we are within that defined coordinate system. To do that, we use program P20 Station Establish. We have another video showing you how to do that. I'll just run through it really quickly so we can get it done. So we're back at P0, program P20 Station Establish. We're at a free station, so we're going to select 2. Our job number is TRS, that's good. And these are good. And our occupied station is RS1. So, yes. We're going to measure height on this. So let's say yes. So it's asking for the instrument height. Now, if you didn't measure it, like I haven't, then go ahead and measure it right now. Shouldn't have changed since last time. 4.99. 4.98. So we're at 4.98 feet. And those are survey feet, by the way. It's prompting us for an area file. Go into alpha mode, TRS. It's an internal memory number 1. And the point number is not B. Okay, so it's asking us to enter a point for our first point. And we're going to select 0 station because it has the elevation reference with it. So it's called ZS. It's asking confirm it. North 0, east 0, 1,000 feet. Yeah, that's the one. And the target height down there was 8 feet. All right. So we're going to aim it at it. No, that's pretty close. So go ahead and aim it, measure, registrate it. Now our next point is prompting us for our next point. And we don't want 0, we don't want to take the default, we want to give it the second point, which is point B. So let's enter point B. And it's prompting us, is that the point we had in mind? And remember, it is. So let's swing around and grab that point with the sun in our eyes. Let's take the measurement. And let's registrate it. When you hit registrate for that second point, the total station's computer does an automatic calculation for the resection and displays the result on the screen. SF, I don't know what it means, so we'll ignore it for now, pretend we don't see it. And standard deviation of 0.015 feet. That's pretty darn close for our use. You know, it could be off by a foot and we'd be fine with it too, but 0.015 of a foot is, you know, pretty good. So we'll take that. But it's asking if we want to do a third point. And we do have a third point we could tie in, but we don't want to use that because we don't know where it is yet. So the answer is no. Now, it calculates, again, it goes through a calculation figuring out the northing and easting coordinate of the total station, so where we're at, to a standard deviation of 0.015. Now if you hit enter, it'll show you what the standard deviation for the north bearing is and the east bearing, and it's 0.01 feet for both of them. I'd say that's pretty darn good. So let's hit enter again, and it's telling us that the elevation of this total station here is 1,029.905. So that's pretty good. Remember, we gave that an elevation, it computed that elevation, and now it computed this elevation. Replace Z, yes. Store, yes. In the area file TRS, in internal memory 1. So now now it's storing that, and it pops us out of Establish Station back to P0. And now it shows us the horizontal angle from our grid that we've created. And it's asking us what our horizontal angle reference is. Well, we're going to accept this as the reference because we've tied it in to a pre-existing grid. Remember, we defined it with the origin and a northing. So we just hit enter to accept the default. Now let's just move that so we don't hear the buzz. Let's go and check what we have now in our file. So menu, 2 for editor, 1 internal memory, return, go to the beginning, and let's step through everything. So first is the 0 station, which we entered in originally, our point A, which we measured, point B, which we measured, and now we have a reference station that was calculated with the resection program within the Trimble itself. And it shows us all so, as I was saying before, some measurements go into the job file, some go into the area file. The station establishment goes into the area file. So all the data associated with that resection we just did is there in the area file, so you can go back and look for it later. And we've defined this reference station 1, so we can now use this over and over again for measuring coordinates and doing all our other stuff. So let me do one last thing before we jump into actually measuring coordinates, and that is to use the program 21 Z/IZ to measure elevation. So what this program does is it averages the elevations that you measure on your grid to create the occupied station's elevation. We only have one point that, well, we have 2 points that we know the elevation of, but we only have one point in the memory that has an explicitly defined elevation, and that's the 1,000-foot reference over at our origin. So we'll just use that one point, and it'll establish this reference, which it already did, but I'll show you how to use this program to do that. First one is select program 21. ZIZ. Now we're at the occupied station is RS1, so let's just accept that. It's an internal memory, so select 1. The area file is TRS, yes. And the instrument height we've already established at 4.98, so yes. And the point number we're going to select is the 0 station. And it has an elevation of 1,000, so that's correct, so let's just accept it. And the target height is 8 feet. That's what the prism is set at. So now let's adjust it. There it is. Let's measure it. And let's see what it came out at. It measured 999.945. So let's registrate that. And it's asking, do we want to do any more points? Now, if we had more points, like point B, we knew the elevation of, which we do, but it's not stored in the area file. We could go ahead and swing this around, take that one, and if there's a third point, we could swing it around to the third point, take that. It would average those to arrive at what the elevation of this occupied station is. We only have the 1 point, so more gets the no. And it says our elevation is 1,029.955. That's pretty good. So it's asking if we want to store that. Sure, why not? And we're going to store it in the area file, so hit enter, yes. Replace the current. It's asking if we want to use that elevation and replace whatever elevation it was at. Say sure, because we trust it. And now we're done. It pops us back into program 0. There we have it. So, where are we? Well, we know exactly where we are on the grid now. It's reference station 1 has been completely defined, and we have a northing, an easting, and an elevation, and we are ready to go and gather points for our topography. So we'll show you how to do at least one point, because remember, we have that third monument that we want to get. So let's go ahead and do that. And in order to do that, we're going to use program 30 enter coordinates. No, program 30 measure coordinates. So program 30 measure coordinates. We're at the occupied station RS1, yes. We're going to use the area file TRS, yes. We're going to accept these defaults, yes. We're going to just call it point C to be consistent with our pretty sophisticated naming convention: A, B, C, D, E. You get it. It keeps going. Point code. Well, we don't know that it's an actual bound, so we're going to just call it a marker for now. So MKR, marker. The target height, the prism has been set up at 4.85 feet. Because that's a fixed rod that I have, and it just happens to put the prism right at 4.85000 feet. So let's swing this around and see if we can't pull that in. Remember, I set this up for line of sight to these 3 points, so we should be able to see it. But the sun's in my eye, so we don't know. Where'd it go? It's there somewhere. Oh, I see it. Okay, here we go. We're going to go ahead and measure that. And it gives us a northing, an easting, and an elevation. And if we hit enter, it'll tell us the horizontal angle, the vertical angle, and the sight distance from where we are. The horizontal angle, the horizontal distance, and the vertical distance. So let's go ahead and registrate this. It's asking if we want to do more. It's pretty windy. It's pretty cold. I think we're all set, so no. So that's a wrap. We covered a lot of ground today, showed you how to use 4 programs to get set up to do a topographic survey. To quickly recap, we established our frame of reference. We nailed down our coordinate system grid. We tied it in to 2 property bounds that we found on site. And in order to do that, we started off by using program 26, which measured the distance between those 2 reference points. Then we used program 43, enter coordinates, to put those 2 points on our coordinate system in a file, so the total station was aware of those points on our grid. Then we used program 20 to establish the reference station here and put our reference station on that same grid. Then we used program 21 to figure out what the elevation reference for the reference station was based on our defined elevation reference of 1000. And then finally, we were able to start using program 30, enter or measure coordinates, so we could start our topographic survey. And we grabbed our 3rd boundary. Well, we don't know it's a boundary, but it's a monument. We call it a marker. And we continue. We grab our well location. We map our stone wall. We find our trees. We take a bunch of points in the field to get an elevation, contours, etc., etc. That's for another time. It's getting cold. It's getting windy. It's actually lunchtime. So thanks for joining us. Thanks for watching. And we'll see you on the next one. Hellbilly out.